Hi, this is Mr. Heichel. I'm bringing you a gas laws review. I'm going to work through these problems with you. I'm going to leave some of them to do on your own. I'm going to do most of them with you. So let's start with number one. It says, what is the standard temperature in degrees C and then in Kelvin? Well, we know that standard temperature in Celsius is 0 degrees Celsius. And then in Kelvin, remember, to get Celsius to Kelvin, we simply add 273. So our standard in Celsius is 0. So we add 273 to that, and we get 273 K for our standard temperature. Our standard pressure, it says in ATM and then in kPa, which is kilopascals. So our standard pressure is 1 ATM. It's also 101.325 kPa, and then we can also use 760 millimeters of mercury if we needed to. So now we're going to start with the problems. You have the problems, so I'm going to simply read them off the screen and show you the work on a different sheet of paper. So the very first problem says the capacity of a scuba tank is 10 cubic feet at 200 kilopascals. If the diver descends to a depth of 150 feet, the pressure is increased by 6 times. What is the volume of the tank? Okay, so we've got pressure, we've got volume. So our formula is Boyle. We do P1 V1 equals P2 V2, and then we're going to plug in our numbers. So our first pressure is 200 kPa. Our first volume is 10 cubic feet, and we know that that equals, it says our pressure is increased 6 times, so you do 200 times 6, which gives us 1200 kilopascals, and we're solving for V2. So V2 is going to equal, we've got 1200 attached to the V2, so we're going to do the opposite of it. So we're going to divide both sides by 1200. So V2 is going to equal 200 times 10 divided by 1200. So if you're doing them on calculators in this class, this is what you're going to do. You're going to do 200 times 10. Hang on, let me see if I can get you a little more light. 200 times 10. Enter, divided by 1200. That's going to give us a volume of 1.67 feet cubed, or cubic feet. So that's that problem. Not very difficult yet. Problem number 4 says 45.3 liters of hydrogen sulfide gas is at 2.54 atmospheres. What is the volume at STP, assuming temperature is constant? So that means we don't need to use temperature. So we're given volume and we're given pressure. So we're going to use the same formula. We're going to use P1 V1 equals P2 V2. Okay, so we're going to start with our first pressure. Our first pressure is 2.45 atmospheres. And we know that we have a volume of 45.3 liters. And that's going to equal, well, our standard pressure equivalency of ATM is going to be 1 ATM. So 1 ATM equals, we're looking for volume, so V2. So our math is going to be the same. V2 is going to equal 2.45 times 45.3 divided by 1. So we just simply do 2.54 times 45.3, and that gives us 110.99 liters. Because you're dividing by 1, so there's really nothing to divide by. Problem 5. If a gas occupies 45.8 liters at 250 Kelvin, what will the temperature be when the volume is 14.2 liters? Okay, so this one we've got volume over temperature equals the second volume over the second temperature. So that's going to equal. So our first volume was 45.8 liters. Our first temperature was 250 Kelvin. Since it's in Kelvin, we don't have to convert, only if it's in Celsius. It says, what would the temperature be when the volume is decreased, or just is, 14.2 liters. So we're solving for T2. So on these, you simply cross multiply. So you would do 250 times 14.2. That equals 3,550. We divide that by 45.8, and we get 77.51 Kelvin. 77.51 Kelvin. Okay, on to the next one. So we're on question number 6. It says, what is the pressure in a container? So we're looking for pressure right away. That contains nitrogen at 35.2 kPa and hydrogen at 75.9 kPa. This is something we haven't covered yet, but it's really simple, and that's why I don't think I covered it. So this is what's called Dalton's law of partial pressure. He says that the partial pressures of all the gases in a container equal the total pressure of the container. So you simply would just add these two things together. 35.2 plus 75.9 gives us 111.1 kPa. So that's Dalton's law of partial pressure. It's number 6. Number 7. If I have a balloon with a volume of 560 milliliters that is filled with 0.75 moles of gas, what is the new volume if I add 1.44 more liters of that gas? Okay, so we're given volume and moles, but we're given two different equivalencies of our volume. So we're given 560 here, and our answer has to be in, we're also given liters. So let's convert 560 milliliters to liters first, and that's just going to be 0.56 liters. Okay, so this law is Avogadro's law, and he says that volume over the number of moles is equal to the second volume over the second number of moles. So our first volume is 0.56 liters. Our moles is 0.75 moles. And we're looking, what is the new volume if we add, let's just do the new number of moles. How about that? So then we got 2 liters, because I think there's a typo one. I think it says, what is the new number of moles if I add that many liters of gas? So let's do that. So then we've got that, so we're going to solve for that. So you do 0.75 times 2. And divide that by 0.56. So 0.75 times 2 divided by 0.56. So 2.67 moles. Sorry, that was a typo. Number 8. If a gas occupies 40 liters at 25 degrees C and 110 kilopascals, what will the pressure be when the volume is 250 liters at 50 degrees C? So this is the combined gas law because we have pressure, volume, and temperature. So P1 V1 over T1 equals P2 V2 over T2. So let's plug in our numbers. So we've got 40 liters, which is our volume 1. So 40 liters. Our pressure is 110. We're given temperature in Celsius. We were given 25 degrees C, so we're going to convert that to Kelvin by adding 273. So we got 298. It says, what will the pressure be? So we're solving for P2. It says our volume is changed to 250 liters, and our temperature went up 25 degrees. So we would do 273 plus 50. So we got 323. So then you do the same thing we did on this previous problem. You cross multiply. So we're going to do the way I would do it on these calculators because they're a little weird sometimes. scoot that over so you can see the calculations. I would do 110 times 40 times 323. Okay? Then I would divide, open my parentheses, 298 times 250, close parentheses, and lo and behold, I get a pressure of 19.07 kPa. So that was number 8. Number 9. A gas occupies 45 liters at standard temperature. At what temperature would the volume be 21 liters? So we're given we're given volume and temperature. Right? So we're using V1, T1, V2, T2. So on your test, you're going to be given very similar worded problems. You're going to have to figure out what gas law you use. But remember, if you use the combined gas law, you just use what you have and cover up what you don't. So we're using this formula. We weren't given a pressure equivalency. Right? We were given volume. We were given temperature. So that's all we're using. So our volume is 45 liters. Standard temperature, remember standard temperature is 273 K. Okay? It says at what temperature? So we're solving for T2. And our new volume is 21 liters. So we do 273 times 21. And then we're going to divide that by 45. And you should get 127.4 Kelvin. Number 10. A gas occupies 40 liters at negative 5.5 degrees Celsius. If the volume increases to 85 liters, how many degrees has the temperature increased? So we are given volume and we are given temperature. Volume 1, temperature 1, volume 2, temperature 2. And then we have to do one more step at the end, and I'll show you on this one. So 40 liters is our first volume. So we do 273 minus 5.5 because we have a negative temperature. So we get 276.5 equals, it says if the volume increases to 85 liters, what is the change in the temperature? So we're solving for T2. So we do 85 times 267.5, and then we're going to divide that by 40. Okay, so our T2 equals 568, but it says what is the change? How many degrees did the temperature increase? So we take this number and we subtract this number. So we do 568 minus 267.5, and it increased 300 degrees or 300 Kelvin. Because remember, we don't use degree when we talk about Kelvin. Let's flip it over. Number 11. Number 11 states a gas occupies 175 milliliters at standard temperature and pressure. What is the volume at 150 C and 4 ATM? So we've got everything. We've got pressure, we've got volume, and we've got temperature. And we have to solve for something else on the 2 side. So occupies 175 milliliters. That's our volume 1. Standard temperature and pressure. Since we were given ATM on this side, our standard pressure is going to be 1 ATM. So we got 1 ATM, 175 milliliters. Our standard temperature is 273 Kelvin. And it says it changes, we're looking for V2, so it changes our pressure to 4, V2, and our temperature changes to 150 C, so we do 150 plus 273, which gives us 423. And then again, you're just going to simply cross multiply and divide. So you would do 175 times 423. I multiply this times this, and I'm going to divide by these two multiplied together. So then divide, open my parentheses, 273 times 4. That's going to give you 67.8. And our unit we were given is milliliters because we started with milliliters. So that would be our answer. Number 12. It says nitrox is a mixture of nitrogen and oxygen gases that allow sport divers to stay submerged longer. If the total pressure in the scuba tank is 250 psi and the pressure of the oxygen is 800 psi, what is the pressure of the nitrogen? We'll go back to Dalton's law of partial pressure. The total is 250 psi. The oxygen is 800 of that. So you just subtract. So the difference is 1700 psi. So the nitrogen is 1700 psi. 13. A gas occupies 400 liters at 125 C and 150 kilopascals. What will be the volume at negative 15 C and 99 kilopascals? So we're going to use the combined gas law because we've got three things. So our first pressure is 150. Our first volume is 400. Our first temperature, we do 125 plus 273, which gives us 398. And that's going to be set equal to, it says what will the volume be? So we're changing our pressure to 99. We're solving for V2. And our temperature is simply 273 minus 15 this time around. So it decreases to 258 Kelvin. So again, we cross multiply. We're going to take 398. Sorry, we're going to take 150 times 400 times 258 and divide it by these two multiplied together. So I'll show you the steps again on the calculator just so you know kind of what we're doing here. I'm going to cover that. There you go. So we're going to do 150 times 400 times 258. So I multiplied this times that. I got a really big number, and I'm going to divide it by. Be sure you open your parentheses. 398 times 99. Close your parentheses, and you get 392.87. And since we were given liters, our answer is in liters. 14. If you have 5.56 moles of nitrogen gas at 375 K and 985 millimeters of mercury, what is the volume? Well, we have a gas law called the ideal gas law where PV equals nRT. Pressure, volume, N is the number of moles, R is a constant, T is temperature. We were given everything except for volume. So we were given a pressure of 985 times V equals N, our number of moles would be 5.56. Our temperature is 375. It's already in Kelvin, so we don't have to convert. And then this R constant that I'm talking about comes from these numbers at the bottom. Since our unit of pressure was in millimeters of mercury, we found the one that has millimeters of mercury, and it is this one, 62.4 would be our R value. So to solve for V equals 5.56 times 62.4 times 375 divide both sides by the same thing, right? To get V by itself, divided by 985. So we would do 5.56 times 62.4 times 375 equals divided by 985. We get 132 liters. 15. 75 moles of gas at 38 C and 951 millimeters of mercury has what volume? So you do the same thing. So 75 moles, we have pressure of 951 equals, we're solving for V, me write it in the right order. So pressure is 951. 951 times V equals, our number of moles is 75, which is a lot of moles. Our R value, since we were given millimeters of mercury, is 62.4. It's a constant. And then our temperature, we take 38C, and we're going to add 273 to it. And that gives us 311. So we're going to do the same steps that we did up here. I'm just going to do it for you and give you the answer. So we do that divided by 951 to give us V. 75 times 62.4 times 311 divided by 951. It's going to give us a volume of 1,530 liters, which is a lot because we have a lot of moles of gas, and it takes a lot to contain that many moles of gas. Remember that 1 mole of any gas occupies 22.4 liters of space. I think I'm going to let you do 16 and 17 on your own. If you need any help, please let me know. And that is it. You'll be ready for the test if you understand these concepts.